Section 4.1 Interactive Assignment Objective 5. Lyme disease is an inflammatory disease that results in a skin rash and flu-like symptoms. It is transmitted through the bite of an infected deer tick. The following data represent the number of reported cases of Lyme disease and the number of drowning deaths for a rural county. We want to complete parts A through C below. First thing we want to do is we want to draw a scatter diagram of the data, and then we're going to choose the correct graph below. So we're going to click on the icon here. We're going to load up the data here, and so we're going to go ahead and then select Open Up in StatCrunch. Okay, so I'm going to go ahead and close this part and then open that back up. Okay, now what we want to do is we want to create a scatter plot using the first two columns because these have quantitative data. So we're going to select Graph and then select Scatter Plot. We have the X variable, which is the cases of Lyme disease, which is the explanatory variable. And the Y variable is the drowning deaths. And then scrolling down here, we want to make sure that points are highlighted. And then we're going to select Compute. So it looks like we have a kind of a positive situation going on over here. So if we take a look at Part A, we cannot include Part A because it's going downward. Okay, so if we take a look at the following values, okay, so let's take a look here. If we take a look at this one example, okay, and go a little further, okay, we can compare this result with our graph. Okay, so let's take a look at that. Okay, it looks like we have 1, 2, 3, 4, 5, 6, 7 points here. So if we look at that further, then this is a clear way of looking at that. So does that match our graph here? Well, it's close, and it looks like it could be this. So now let's go back to the other choices. Okay, we're going to go to C. Okay, so if we take a look at C and then compare our graph, well, it looks a lot different because you have these points up here and these all points are located down there. So we can eliminate C. And now let's take a look at D. So if we take a look at D and compare this here, well, again, these are kind of all bunched together. We have this and this point here, and you can see that this one doesn't work. So it looks like when we take a look at C again, okay, this is C. This looks like that matches with our graph here. So let's go ahead, B. So we're going to go ahead and select B and see if that works, and that works. That matches our scatter plot. Okay, now it says determine the linear correlation coefficient between Lyme disease and drowning deaths. So we need to round this to 3 decimal places. So we're going to come back to our data, and then we're going to close out of this, and now we're going to go to Stat, and then we're going to select Summary Stats, and we're going to go to Correlation. And then we're going to highlight both cases of Lyme disease and drowning deaths. Okay, and now we're going to go ahead and select Compute. Okay, so if we take a look at our value here, okay, this is to 3 decimal places, and we need to round that up because the 5 is going to tell us to round that 4 up, so it's going to be 0.965. So let's go ahead and put that into 0.965. Okay, and let's check our answer, and then we have our linear correlation coefficient. Now it says, does a linear relation exist between the number of reported cases of Lyme disease and the number of drowning deaths? Well, what we need to do is we need to figure out what is the critical value. So the first thing we're going to do is we're going to write down what our linear correlation coefficient is, which is 0.965. So let's go ahead and do that. So the linear correlation coefficient is 0.965. And remember that we need to take the absolute value of this number, and when we take the absolute value, it's going to give us 0.965. Okay, and now we need to compare that to the critical value. So we need to know what is the sample size. Okay, so going back to our question, okay, if we take a look at the data here, well, how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the sample size is 12. So we know that n is equal to 12. And now we need to find the critical value associated with n is equal to 12. So we're going to come back over here where it says click on to view the critical value tables. So critical value, we're going to go all the way down and we look at 12, and that gives us 0.576. So we know the critical value is going to be 0.576. Now, since the linear correlation coefficient is greater than the critical value, then we can say that a linear relation exists. So now let's answer our question. Okay, it says here, the variables Lyme disease and the drowning deaths are what? Well, we know that it's positive because it's a positive graph, so it's positively associated because R is positive, and the absolute value of the correlation coefficient was 0.965. Okay, and that is greater than the critical value that we found, and the critical that we founded was 0.576. So that is 0.576. Checking our answer, and then there is our result. Now it says, do you believe that an increase of Lyme disease causes an increase in drowning deaths? What is a likely lurking variable between cases of Lyme disease and drowning deaths? So the answer would be an increase in Lyme disease does not cause an increase in drowning deaths. The temperatures and time of year are likely lurking variables.